Hi everyone, welcome to my channel Edu-spectra. So now let's do our rest of the questions. Okay, so next question number 4. In the figure, if lines PQ and RS intersect at point P such that angle PRT is equal to 40 degree, angle RPT is equal to 95 and angle TSQ is equal to 75 degree, find the value of angle SQT. Okay, so angle SQT I have taken it as X over here. Okay, so let's find the value of angle X. So first of all, just we have to consider this triangle PRT. Okay, first of all consider triangle PRT. So if you see over here, can we find this angle over here? That is angle PTR, isn't it? Yes, by angles are property of triangle. So from here I can write 95 plus 40 plus this angle PTR. Okay, PTR is equal to 180 degree. So 95 plus 40 it is 135 plus angle PTR is equal to 180 degree. So from here you will be getting angle PTR is equal to 180 minus 135 which is equal to 45 degree. Okay. So this we deducing our angle sum property. So this angle we got it as 45 degree. Okay. Now if you see over here, this angle PPR and this angle STQ, aren't they equal? Yes, because they are vertically opposite angle. So you can write angle PPR is equal to angle STQ is equal to 45 degree because they are vertically opposite angles. Okay. So now let us consider the second triangle over here, that is triangle STQ. Okay, we are considering the triangle STQ. So here also we can use our angle sum property of triangle. So we can write 45 plus 75 plus x, that is what we need to find, is equal to 180 degree. So 45 plus 75 which is 120 plus x is equal to 180 degree. So from here you will be getting x is equal to 180 minus 120. So 180 minus 120 it is 60 degree. Okay, so from here we found the value of angle SQT. Angle SQT is equal to 60 degree. Okay, I hope it is clear. So now let's move on to our fifth question. The question is, if PQ is perpendicular to PS and PQ is parallel to SR, angle SQR is equal to 28 degree, angle QRT is equal to 65, then find the values of X and Y. Okay, we need to find the value of X and Y over here. Okay, so first of all, in order to find X and Y, let us consider an angle Z over here. Okay, now if you see over here, this angle 65 degree, it is formed towards the exterior side of the triangle. So if you consider this triangle QSR, then the 65 is the exterior angle of this triangle. So we know exterior angle is equal to sum of two opposite interior angles. Okay, so from here I can write 65 is equal to this angle Z plus 28. Okay, this we have written using our exterior angle property. So from here you will be getting Z is equal to 65 minus 28. So you will be getting Z is equal to 37 degree. Okay, that is we got this angle is equal to 37 degree. Okay, now if you consider this angle Z and this angle X over here, okay, they forms a Z like shape over here. This angle is 37 we got, so this angle will also be equal to 37 degree, isn't it? Yes, we know they are alternate interior angles. So from here we can say that angle Z is equal to angle X because they are alternate interior angle. So we can say that angle X is equal to 37 degree. Okay, so we found the value of X is equal to 37 degree. This is 37 degree. Okay, Now we need to find the value of y. Okay, so in order to find the value of y, let us consider the triangle PQS. Okay, so if we consider the triangle PQS, we know that the angle sum of all these angles will be equal to 180. So from here I can write 90 plus 37 plus y is equal to 180 degree. So 90 plus 37, it is 127 plus y is equal to 180. So y is equal to 180 minus 127 to 53 degree. Okay, so from here we got angle y is equal to 53. Okay, so x we got 37 degree and y we got 53 degree. Okay, so I hope it is clear. Okay, so now let's move on to the sixth question. Okay, so it's a important question. The question is, in figure, the side QR of triangle PQR. Okay, this is QR is produced to a point S. That means we are extending this line. If the bisectors of angle PQR and PRS meet at point T. Okay, these are the angle bisectors and it meets at the point T. Then prove that angle QTR is equal to half of angle QPR. Okay. So let's see how will we do the question. Now here, first of all, we have to just separate these two figures and identify the two triangles over here. Now first of all, I am considering the triangle PQR. Okay, so this is the triangle PQR and I have drawn it separately over here without the angle bisectors. Okay, so this is the triangle PQR. Now if you see over here, this angle PRS, it forms an exterior angle, isn't it? So here we can apply an exterior angle property. That is, exterior angle is equal to sum of two opposite interior angle. So from here I can write angle PRS is equal to angle RQP is equal to angle RQP plus angle RPQ plus angle RPQ. Isn't it? This we have written using our exterior angle property. Now our next step is we have to multiply a half in both the LHS and RHS. Okay, because in the question there is a half, we should multiply both the LHS and RHS with a half. So we will be getting half of angle PRS is equal to half of angle RQP plus half angle RPQ. Okay, we multiplied a half over here. Just let us go back to our main figure over here. Just see over here, half of angle PRS. Now this is the full angle. Okay, PRS is the full angle in this figure. So when we say half of angle PRS, it means that it could be either this angle or this angle, isn't it? So half means these two angles together makes this full angle PRS. So half means this angle or this angle. So now in order to do our question, we should consider this angle PRS. So half of angle PRS is either this or this. So for doing a question, we are considering it to be PRS. Okay, here I am writing angle PRS is equal to, similarly, now half of angle RQP. So just see over here, this is the angle RQP. Okay, so here also RQP is this full angle. So half of RQP means either this angle or this angle. Okay, so in order to do the question, we should consider angle PQR. Okay, so here I am writing, instead of half of RQP, I am considering this angle PQR because it is half plus half of this RPQ I am leaving as it is. So here if you see, in our question it is PQR, right? So instead of RPQ, let us rearrange and write it as QPR. Okay, this you don't need to make any change, leave as it is. Okay, so this you can consider it as equation number 1. Now let us consider the second triangle. Okay, PQR. This was our first triangle. Now the second triangle is this triangle, which is QTR. Okay, I have drawn it separately over here. Here also you can see there's an exterior angle being formed over here. So here also we can apply a exterior angle property. So from here I can write angle TRS. Okay, angle TRS is equal to angle PQR. Okay, that is this angle plus angle QTR plus angle QPR. Okay, this we have written using our exterior angle property. Now, just see over here, this we can give it as equation number 2. Now, if you see over here, if you just compare equation 1 and 2, both of them are equal to PRS, isn't it? So, from here, since the LHS of both of them are equal, can't we equate the RHS? Yes. So, by combining equation 1 and 2, we can write angle PQR plus half of angle QPR is equal to, then this one is equal to angle PQR plus angle QPR. Okay, we have written it like this. Now if you see over here, angle TQR and angle TQR are common over here. So if you bring it to the side, it will come into minus. So TQR minus TQR, it will cancel off. So from here itself we can cancel it off. Okay, so from here if you see angle QTR is over here, so I am taking it to the other side. So angle QTR is equal to what is left over here? Half of angle QPR. Isn't it? So this was exactly what was asked to prove in a question. Okay, so I hope it is clear. Okay, so now let's move on to our example number 8. The question is, in the figure, the sides AB and AC, okay, ABAC of triangle ABC are produced to points E and B respectively. That means we are just extending these lines to E and B. Okay, if bisectors BO and CO, so this BO and CO are angle bisectors. Angle bisector means it divides into two equal halves. Okay, so the angle bisectors meet at point O, then we have to prove that angle BOC is equal to 90 minus half of angle BAC. Okay, so let's see how will you do the proof. So let's see how will we do. This is a very important question. Now, if you see over here, this is the thing we need to prove. In our question, it is given that BO and CO are angle bisectors, which means that it divides this full angle and this full angle into two equal halves. Okay, so if you see over here, the full angle is EBC. Okay, so this EBC can be, we can say that angle EBO is equal to angle CBO because they are angle bisectors. Similarly, this angle BCO and BCO, okay, BCO, they are also equal because they are angle bisectors to each other. Okay, so that is given to you. Now, first of all, let us consider this triangle ABC. Okay, so if you consider this triangle ABC, we know according to angle sum property, we can say that x plus y plus z, the sum of interior angle is equal to 180 degree. Now, in order to do our proof, let us keep this y plus z on one side and let us take the other things to the other side. So we will be getting y plus z is equal to 180 minus x. Okay, we can consider it as equation number 1. Now, let's see. Now here, if you see this full angle over here, okay, this full angle together makes a linear pair, isn't it? That is angle ABC. Okay, this full angle over here, this angle ABC and this angle EBC. Okay, this full angle, they together makes 180 degree, isn't it? Because they form a linear pair. So we can say that angle ABC plus angle EBC is equal to 180 degree. Okay, now this angle EBC, we know we can just split it and write it as angle EBO and angle CBO. Okay, because this individual angle and this individual angle together makes this full angle EBC. Okay, so angle ABC plus angle EBO plus angle CBO is equal to 180 degree. Okay. Now I have considered the angle CBO as angle 1. Okay, for our simplicity. Now it was given to you that they are angle bisectors, so EBO is equal to CBO. So here instead of this angle EBO, I am substituting it with CBO. So from here I will be getting angle ABC plus angle CBO plus angle CBO is equal to 180 degree. So CBO plus CBO, just twice of angle CBO is equal to 180 degree. So in our figure, I have named angle CBO as angle 1. Okay, and if you see this angle ABC, that is this angle, that is equal to y. Okay, I have named it as y. So angle y plus twice of angle 1 is equal to 180. Now let us keep angle 1 on one side and take other things to the other side. So we will be getting angle 1 is equal to 180 minus y by 2. Now this 2 is common to both 180 and y, so we can just split it and write. So 180 by 2, it is 90 minus y by 2. So we got angle 1 is equal to 90 minus y by 2. Let us consider it as equation number 2. Okay. Now the same thing that we did over here, we should do over here also. Here also, if you see this angle ACB and BCD, they also forms a linear pair. The same step that we have done over here, we should do. Okay, but in our exams and all, we need not repeat these steps. Now, if you see over here, we got angle 1 is equal to 90 minus y by 2. So, similarly, here we are having the angle 2. Okay, by doing the same step also, you will be getting the final answer as angle 2 is equal to 90 minus z by 2. So, you should understand the pattern that you are getting over here. So, here angle 1 is equal to 90 minus y by 2. Here also this 2 will be 90 minus z by 2. So, here the angle was y, so we got y by 2. Here the angle is z, so we will be getting z by 2. Okay, so you don't need to do here also like take the linear pair and do all those steps. You can directly write angle 2 is equal to 90 minus z by 2. Okay, so this you can consider it as equation number 3. Okay, now let us consider this triangle BOC now. Okay, that is this triangle BOC. Now here also we can use an angle sum property of triangle. So we know the interior angle is equal to 180. So angle 1 plus angle 2 plus angle BOC is equal to 180 degree. 1 plus 2 plus BOC. Okay, now we had found the value of angle 1 and angle 2, isn't it? We can just substitute it in place of 1 and 2. So angle 1 was 90 minus y by 2 plus 90 minus z by 2 plus angle BOC leave as it is equal to 180 degree. Okay. Now 90 plus 90 group together, minus y by 2 plus minus z by 2 plus angle BOC is equal to 180. So 90 plus 90 it is 180 minus y by 2 plus minus z by 2 plus angle BOC is equal to 180. Now 180 is common in both LHS and RHS, so we can just cancel it off. So you will be getting angle BOC keep on one side and take the other things to the other side. So angle BOC is equal to y by 2 plus z by 2. Okay, now from here we can take half common. So when you take half common, angle BOC is equal to half of y plus z. Okay, we have took 1 by 2 common from both these terms. Now here, if you see what is y plus z, now we had written over here our equation number 1, isn't it? If you remember, so y plus z we had said that it is equal to 180 minus x. So instead of y plus z, we can substitute 180 minus x. Okay, so we will be getting angle BOC is equal to half of 180 minus x. Okay, we have done substitution over here. Now here just open the bracket. So angle BOC is equal to 180 by 2 minus x by 2. Okay, so 180 by 2 when you cancel you will be getting 90. Similarly x by 2 you can write it out. You can write now. If you see what is angle x in the figure, it is angle BAC. So instead of x you can write angle BAC. So finally you will be getting angle BOC is equal to 90 minus half, if you take common, 90 minus half of angle BAC. Okay, this was the thing we need to prove. Okay, so I hope it is clear. So we have completed this chapter. So I hope all the questions that we did today are clear. Now we will be meeting in our next video with the next chapter. Thank you. Please like, share and subscribe the channel.